Hear me okay?
Yeah, yeah, I can hear you quite well, I guess.
Okay, cool. Thanks for joining me in this experiment. Um, I hope it goes well. Um,
Yeah,
I'm I don't really have a good idea how to do this, but maybe we could just start with a short introduction.
yeah,
Is that okay with you? Should I start?
yeah, sure.
Okay. So I'm Felix.
Yep.
I'm studying computer science currently.
Mm-hmm.
Um, I'm interested in all this future of coding stuff since, I don't know, maybe a year or so.
Mm-hmm.
Um, and I've been doing a couple of small experiments, but nothing too big so far, and nothing really that had worked out. Um, but thinking about this and afterwards, um, it was really just two large projects, and I didn't really understand what I was doing back
Mm-hmm.
then. Actually, I think most of the people in the group don't really know what they're doing because it's just really hard stuff.
Yeah.
Um, but yeah, I'm currently starting my master's thesis
Uh-huh.
um, with in another field, which is not really related to the future of coding stuff of the group.
But
Um,
it's about computer science still, right?
yes, it's computer science. It's about um, pattern matching source code files.
Mm-hmm.
Um, like you take the AST of a program,
Yeah.
um, and I'm developing something like regular expressions
Uh-huh.
for an AST.
Okay, I see,
So
I see.
yeah, so that you can in my case that you can write custom lints. So
Custom what?
for ex c-
Lenses or
lints, LINTS. Um,
Lints? Ah, lint,
that's
lint. Yeah, okay, I got.
yes.
Mm-hmm.
So if you, for example, if you have two if clauses
Mm-hmm.
directly into each other,
Mm-hmm.
you could write simpler code by just replacing them with one single one
Mm-hmm.
and combining the two conditions.
Mm-hmm.
Okay.
Yeah, I see, I see.
And what I'm working on is a tool that does these kinds of analysis and suggests these kinds of fixes.
Mm-hmm.
But currently, designing such a tool is pretty hard because you have to write custom code for each of these rules.
Mm-hmm.
And my plan is to develop something, yeah, probably like regex.
Yeah, some kind
Um,
of DSL.
yeah, kind of. So that you can really easy just write code and have some wildcards in there saying, okay, I want a function, but I don't care the name of the function
Mm-hmm.
as long as it's a function with an if inside or something like that.
Mm-hmm.
And then an engine that can take syntax trees and analyze them.
Mm-hmm.
That's the plan, but I just started 3 weeks ago, so I don't really know where it's going.
Yeah,
Yeah.
but I think that's what optimizers in compilers do, right? So they take tree and they match like you do, and
Hmm.
they like optimize, remove parts, produce another tree, and then another optimizers, like several stages.
Hmm.
It's really similar.
Yeah, I think there are different domains in which you need to match these kinds of patterns.
Hmm.
Um, code compiler optimizers are one part.
Yeah.
Simply searching for code
Hmm.
might be another interesting one.
Hmm.
For example, you might want to know where are functions where I'm returning where I have return statements in different multiple return statements, for example.
Hmm. Hmm.
Because you would say, okay, maybe functions can be written easier if there's just one single return statement or so.
Hmm.
Specifying searching for this using regular expressions is really hard because
Yeah.
um, you would need to exactly match the braces to know the depth of code and
Hmm.
so this would be really hard. So this kind of pattern matching could be useful in search as well. And of course, what I'm working on, the lints.
Mm-hmm.
Um, yeah, that's what I'm currently doing, but I think that's not a very very big step like in the stuff that's mostly in the group.
Mm-hmm.
But I'm still interested in that. And after the meeting last week, I don't
Mm-hmm.
know if you were there.
I was there. I remember you.
Okay. Yeah, so many people,
Yeah,
and
yeah, yeah.
actually for me it was pretty late in the evening,
Uh-huh.
and I had a long day. I didn't speak much,
Mm-hmm.
and I could barely stay awake there. So it wasn't the best time for me, but still it was great, and I it inspired me to do this again, maybe in a smaller,
Mm-hmm.
um, just a one-on-one.
Mm-hmm.
And that's why I asked in the group, and I'm glad you showed up.
Yeah, good.
Yeah, that's it from me. Would you
So
like to tell us
introduce.
something about you?
Um. Okay. Well, I started to program like sort of early, like when I was like
Uh-huh.
15 or something, and I always wanted to like to be like a real programmer, to learn to create
Mhm.
programs, do something. Then for some reason, I really liked to learn different programming languages,
Mhm.
and uh, I just really was interested in programming languages themselves, like what language is like more expressive than the other, like what you can
Mhm.
do in one but cannot in the other.
Mhm.
And I at some point I wanted to create my own language, and I like tried to write some kind of interpreter or something,
Mhm.
and I got some progress, but at some point I realized that it's useless. It's like I created really shitty Python. Like
Mhm.
nobody gonna use it. I didn't solve any problem. I didn't bring any value. And then I
Mhm.
stopped and like, okay, so what is the real problem? Like, what problems people have with programming languages that should be solved?
Mhm.
So if I solve it, people gonna use it. So my work could be useful.
Mhm.
And at that point, I really got lost, and I thought, okay, I see nothing. I don't understand, and probably I was a bit even depressed because I really didn't knew what to do.
Mhm.
Then I stumbled upon Brett Victor's work.
Oh
Like,
yeah, that's
yeah,
how most guys come into this area. This
yeah,
is true for me as well.
yeah. And I was like, first I watched like Inventing by Principle. I was
Uh-huh.
really curious about it and thought about it as really futuristic thing. Then I forgot about it for 2 years and,
Okay.
did some other like attempts, research. And then I stumbled upon it again, and I watched like Future of Programming and Seeing Spaces, like two talks.
Yes.
And then I really like I don't know. Suddenly I realized like that programming is not really writing text, and
Mhm.
it's not really in this. It's not. You don't have to be in this rectangle. How Brett says, in this
Mhm.
screen. It's bigger. And then I realized what the problem is, and yeah, and then I tried to uh, like I have this like vision of future, like what things could be, like, what kind of features we could have in daily
Mhm.
life, like what kind of pain we could avoid.
Mhm.
And now I'm just trying to formulate like from which where to start and what problems should be solved first in such a way that they could be in such a way that solutions could be adopted, so people would really use
Mhm.
it, not just like experimental stuff, like some look I created this, not some like academic toy, but something that people would really use. And
Mm.
I write
Yeah, that's a hard part
yeah
actually, because there's so many great things, but just because of legacy and compatibility,
yeah
it's really hard to get people to use them. Yeah.
yeah
But that's an important aspect that should absolutely be kept in mind all the time.
hmm yeah. And I did one project like a
Hmm.
year ago or a year and a half ago. It was inspired by Seeing Spaces, like this talk of Brett Victor.
Mm-hmm.
when he gave an example of like robot who walks and the room records everything, and then they
Mm-hmm.
go back in time and see what happened and try to replay the move. So
Mm-hmm.
like that's how you should debug your complicated program, your robot. And I thought,
Mm-hmm.
okay, what if I could do something similar? Of course, I couldn't build a room, but I thought, what if I record the execution of the program?
Mm-hmm.
And my like one of my favorite languages is Erlang, and Erlang has
Mm-hmm.
really good tracer. So basically, you can get information about the whole execution, what function, like who sent what, who read what, everything.
Mm-hmm.
Really, you can record everything. And I made this visualizer, the thing that records the execution and tries
Mm-hmm.
to visualize it like a map or something. Basically, what I did is just a timeline and different process, and they send messages, so you can see
Mm-hmm.
who sent whom, who
Mm-hmm.
sent who what, and who spawned the new process, who died, and something like this over
Mm-hmm.
time.
Okay, cool.
Yeah, yeah, and I thought, okay, maybe people might be interested in it, or like there might be some kind of interest, so I could, I don't know, maybe get some kind of donation or something, so I could continue to work on it. But then I
Mm-hmm.
realized that it's really too niche and too like really small problem. Not many people gonna gonna use it. So not many money I could like very little money I can get. So I wouldn't be
Yes.
able to fund myself. So it's not really like good way to go. So I stopped, and right now I'm just working my like ordinary job and
Mm-hmm.
prepare to enroll to university.
Okay.
And I hope there I'm gonna have time to work on that kind of project. And for now, just write down like what kind of problem I should solve that gonna
Mm-hmm.
be adopted.
Okay, cool.
Yeah.
It's really interesting that you have ideas first and go to university second. I think that's not what most people do,
Yeah.
but I think there's a great potential because most people come to university and they just learn from the generations before,
Yeah.
and they adopt all the probably false thinking.
Hmm.
And if you already have something in mind,
Hmm.
and then get the time to work on this, this might be really cool.
Hmm.
And of course, if when you're studying, you have a lot more time to spend on personal research as well.
Yeah. That's what I hope for.
Mm.
Yeah, and I hope that
Cool.
I would meet some peers who are also interested in this, and maybe we're gonna form some kind of company or something. Like
Uh,
it must produce money in order to be viable. Like really, it's the
mm.
only way, because you have to pay people so they could work full time, right?
Mm.
So it's
Yeah, I
realistic.
think it's difficult in this domain to get funding
Hmm.
because most ideas are there's no good proof that it's going to work out. So
Hmm.
for investors, it's always going to be a high risk thing,
Yeah.
and they're not that likely to fund this. And also, a lot of people don't really see the problem.
Yeah. Right. Well,
At
it.
least until you show them, hey, um, open your eyes.
Mhm.
You've been coding for 10 years and still you're terrible at finding where your function is. Maybe your tool is just bad. And so you have to. I think it's not that easy to fund in this area,
Mhm.
but I see a great potential, and probably a company is the only way you could get this out to a wider audience.
Yeah. Well, what I think is that um, there might be some like really basic principles uh, that are just not adopted,
Hmm.
and maybe if you solve really not really sexy problems, like you're not creating a new language, you're creating something much more trivial, like I don't know,
Okay.
some kind of personal workspace where you like work with your photos or something. But the basic structure, like the how you work with data, how you share, and what kind of pipelines you can create, may over time evolve into a new programming environment, new VM or something. So maybe you can find a spot where you can solve a problem, not really sexy problem, but the problem that will bring you money, and then you can like grow in it.
Go from there.
It. Yeah.
That's probably a good idea. Okay. So we wanted to talk about structure editors, right?
Yeah. One of
as an alternative to text-based editing.
Yeah.
What's your motivation that you say, okay, we need to go away from text, or what's your take on this?
Well, I think, but I'm not really against text editing.
Okay.
I'm against storing code as text.
Okay.
And I can give you an example. Like, for example, like in the past, we just had like emails, text emails, and we use text, right? But now we have some kind of Facebook or like Telegram, and we exchange video, photo, we quote each other, like retweet or something. We record audio. It's really complicated interaction right now. It's like really graphic, a lot of media. Because we do not exchange a sequence of bytes, we exchange complicated data structures, right? Because audio, like replies like to specific message in the past. It's like it's all connected, and I thought, okay, code must be like that. Code must be a complicated structure that we can edit and work on it in order to provide more features, make it more convenient. Yeah, and for example, when you try to like create a really good IDE that helps you, for example, autocomplete or something else, or some kind of linting. Basically, what you need is you need to parse the code and put it into database, and make and run queries on top of it. So you like so in any like when you type, you should be able to query what kind of functions start with this prefix and give a result to suggest. So basically, we already need a database for code. It's already structured, but we just write it down in bytes. Edit it with bytes. Then we read in the database into structure to provide autocomplete and other features, and then dump it again in text. So I thought, okay, it's not a new idea, but what if we just create such programming language, programming environment, if you would say that, that does not use text as storage. It's always data structure. You always work with data structure. Maybe it looks like text because we're used to it. Maybe we still type, but it's not stored as text. That's important. Yeah, and if you just suggest that, there are interesting like implications go through it.
Yes, absolutely. Okay, I'm totally with you. I'm on the same page. I think I also think that text is the only place where we really should use text is for direct input, because your keyboard just produces text, and for output, because reading text is can be really dense and communicate intentions really well. Programming text is if you get used to it, pretty good to read actually. I think way better than for example all the visual programming boxes and stuff. For people starting out, these are great, but actually if you have something more complex, text is pretty good for reading. And for writing, I mean, your keyboard just produces text, so it's also a good idea to use text there. But the parsing step should occur as you type, and the disambiguation what you meant
Mm-hmm.
should happen as soon as possible, because when you write your code, the IDE can ask, okay, do you mean this variable with the name, or do you mean the module with the same name, or something like
Mm-hmm.
that? And when you write the code, you know what you mean, so you can tell your IDE once,
Mm-hmm.
and then it just stores the exact information into the database,
Yeah.
um, and and then it's just there and it's correct.
Mm-hmm.
Um, that's I think that's a really good idea.
Mm-hmm.
Um, the what I've Do you have an idea how such a structure would look like? Would it be more like an AST, like a tree structure, or more like a graph structure? So you um, could connect the declaration of a variable with its usages and stuff like that.
I was thinking about it. Um, I couldn't come up with anything better than just uh, DAG, like directed acyclic graph, just like Git is, right? You have,
Okay.
and it really looks really convenient. Um, yeah, and what else? Yeah, I would say about, so if you store your code as this kind of data structure,
Hmm.
and you can reference, um, like the thing is that you don't have to use, humans don't have to remember identifiers anymore because of it. So basically, you don't have to type super correctly print f, for example.
Okay.
You just print something and you search in autocomplete or something
Hmm.
database the exact function. There might be like hundreds of print of functions that have the exactly same name, pretty much like in Facebook have many people with exactly same names, but they're
Also, like you use Google for searching for some topic, and you get a lot of similar results, and you can choose the one you really want.
yeah, and so you just connect directly,
Uh-huh.
and basically humans never see this ID. It's always like unique, random, long, like
Hmm.
hash or something. And what's interesting is that you in such a system you're never gonna have like name clash.
Hmm.
It's like you just have your own data structure. For example, some like struct and like fields like next.
Hmm.
For example, if you're talking about linked list, it's next and something.
Hmm.
And some other programmer may create something, and
Hmm.
third programmer like couples it together in one structure and
Hmm.
can use in your code and that code, and they do not conflict at all.
Okay, so each program entity would have a unique hash. Is that what you're saying?
No, I'm saying is that there's no name clash, like no conflict of names in data
Hmm.
structures and in function names, in structure names, in names of types, like in any names.
Okay, because you don't need names to
Yeah,
to say, okay, these two things are the same,
yeah,
because
yeah,
you use explicit
Li-
edges in your graph or something
yeah,
like
yeah,
that.
yeah, yeah,
Okay. Yeah. Yeah, that I mean that sounds so logical.
yeah,
It's amazing that no tool has gained wide adoption that uses these kinds of principles.
yeah.
Um, that's that's really interesting, and um, I'm not sure why it's the case.
Well,
If it's just programmers wanting to stay with their Vim text editor, or if there's another problem, I don't really know.
well, you see, you have to reinvent many things,
Hmm.
and it's hard to do alone. You see, you basically you if you create such kind of language, you basically saying that you're probably not going to use Git because
Hmm.
traditional text-based like versioning
Yeah, I
is
mean, using a text-based div on a non-text file, for example, doesn't make any sense.
yeah,
It's
yeah, yeah,
just,
pain.
yeah, like having a PDF file or something like that. It Git is like many Unix things,
Hmm.
especially built for text. And I think this has been very helpful in the early days.
Hmm.
where computers and tools were much less powerful. But now that we have a lot of tools and people have access
Mm-hmm.
to advanced tools, it's probably time to rethink the Unix philosophy of just everything is text, because we have a lot of complexity just parsing text
Yeah.
and re-encoding it, because the text doesn't naturally represent what we want to express.
Mm-hmm. Yeah, and yeah, what I want to say. Yeah, and imagine that. So one program use. Um, well, I told you that like I said that one programmer can define its own like structure and
Hmm.
names for the fields that have
Hmm.
precisely that purpose that he thought about. The other
Okay.
may create the other like field. Someone else may just create instance of this and this and merge it into single entity,
Okay.
and then one single data structure put in this context it means this, put in that context it means that. And it sounds so cool because you just fetch a record from database, throw it
Hmm.
into one view, and it displays a map and road on it. You
Hmm.
put exactly same data into other context and it shows something else totally different, not map but some other information about say
Hmm.
that person or that object. And it's really, I don't know, it sounds cool and interesting.
Hmm.
Convenient to use. Convenient to use.
Hmm.
Yeah. And what I also want to say is that I stumbled upon ipfs. Maybe you know.
Oh yeah, that's great. I know of it.
And actually, it sounds like it really has this structure that could be used for uh, code.
Hmm.
Really generic structure that can represent any code in this kind
Hmm.
of tree way. And so maybe that's the new text. Maybe that's the.
Okay. So you would go away from files also completely and folders, or would you still want these to be there, or just take each entity of a program like a struct or a function and have them as independent IPFS nodes?
But like in IPFS, there's no difference between like folder, file, or just field, right? It's all just structures, tree structures. For example,
Is it?
mhm,
Is it?
as
I
far
th
as
I thought they still have like some kind of files, which is just binary data.
mhm.
And then also the option to have folders in there or so, but I'm not an expert.
No, as well as far as I understand, what they initially have is just this DAG structure, like pretty much like Git,
Hmm. Hmm.
and if you structure this DAG in a certain way, then you can
Hmm.
mount it to the file system.
Okay.
But in general, it's just a DAG. And yeah, and you can, I think you can store your AST there and mount it to the file system and access your AST as a just folders and files. And
That would be interesting.
yeah, and you know what's it's interesting is that it really clicks with what Plan 9 did because they tried to represent complicated APIs
Hmm.
as files and folders. Really, they they,
Okay.
they went even more hardcore than Unix. They just try to like reduce syscalls to minimum. It's like the only syscall you should most of the time use, like read and write, like read from file, write from file, but really special
Hmm.
file from in this
Hmm.
structure. It really reminds this kind of thing. Like it really clicks like everything together.
That's
Beautiful.
interesting. I haven't heard of it. I need to look that up. Okay. Um, and do you have any specific project ideas right now?
Yeah, I do, but I just don't have time for it. But I can explain maybe.
Yeah, that would be interesting.
Um, I really like this idea of using this DAG, like IPFS
Hmm.
kind of structure, for um, everyday life, everyday problems,
Hmm.
and like in my daily work, I really work a lot with shell, like trying to, like, you know, run some commands, like work
Hmm.
with like SQL shells and something. And I often have to go back, old commands, and sometimes I have to store somewhere the outputs. And I thought, okay, what if we create some kind of shell
Hmm.
that, but unlike the traditional shell, it's gonna be like structural shell. It's not textual. So
Okay.
so every command you run stores the output in a specific like data unit file, if you want a structure
Hmm.
in IPFS, and this command is connected, linked to this data. So if you have this data, you can like follow where it came from,
Hmm.
and uh, this way you just can create different commands that operate on this outputs. Yeah, some kind of workspace that it's convenient to work with. Well, from like on this stage, it doesn't look that useful. It's just interesting, but not useful.
Hmm.
But then I thought further and realized, okay, um, what's one of the problems with shell is that it's really, you really have to remember about context, in what folder you
Hmm.
are, like what value in this file right now, was it changed or not, and
Hmm.
if you can track the changes, the value, the content of files,
Hmm.
then you would feel more safe, and you can repeat runs of the programs more safely.
Hmm.
And then I realized, okay, what if I run every shell command in some kind of container,
Okay.
so I could replace some inputs that it takes
Hmm.
to reproduce an environment I want, and like uh, yeah, I just wanted to turn a command, shell command, into some kind
Hmm.
of function that I can run safely, like without worrying that I'm gonna destroy something. Like
Hmm.
all its inputs and outputs are gonna be under my control, and I can replace it, rerun it,
Hmm.
without worrying that it can destroy something in my system, and create a convenient interface for it where you can store like intermediate results, rerun it.
Hmm.
Yeah, yeah, and you know, like builders, like continuous integration pipelines, they also create something similar. They store intermediate results, rerun it.
Hmm.
They really try to run as little as possible, cache the like
Hmm.
previous outputs, and it's really also clicks with this kind of problems. So,
Yeah. I think content addressing like IPFS does
mm-hmm,
is has a lot of potential for making processes more incremental.
mm-hmm,
So if you rerun, for example, if you have a code compiler,
mm-hmm,
and all compilation stages use hashed values.
mm-hmm,
If you change a little thing, your compilation can just skip a lot of duplicate work
yeah,
in parts where nothing changed actually. So hashing and content addressed stuff is I think really important.
mm-hmm,
And also for code, it would be. I mean, we're using Git
mm-hmm,
because it has content addressing, which means we can be sure we have the same version.
mm-hmm,
Um, but we're using it on this file abstraction,
yeah,
which doesn't really, which is kind of arbitrary.
yeah, yeah, yeah,
Um, there's, I mean, some people write modules that have 10,000s of lines. Others say, okay, just one class, and it doesn't,
do
it
anything.
shouldn't take more than, I don't know, some amount of lines.
Mm-hmm,
Um, and actually, for other kinds of data, a file system does make sense.
mm-hmm,
For example, if you have photos and you want to organize them into different I don't know, this is my vacation last
Mm-hmm.
year and this is the one from this year. Folders do make sense, but for a program has its own structure.
Yeah.
There are actually different structures. There's a static structure, like how different structures or classes interact with each other,
Mm-hmm.
or how they import each other.
Mm-hmm.
There are other structures like runtime dependencies, how call graphs are formed or something like that. And giving users the ability to also have a file abstraction
Mm-hmm.
just introduces more complexity. At least that's what I have experienced.
Yeah.
So most of the time you don't the class you want to look at,
Mm-hmm.
and then you need to find in which file it is. So this file abstraction doesn't really work for coding that well.
Mm-hmm.
Um, so if you would make this great idea of Git that just different things are uniquely identifiable
Mm-hmm.
by their hash, and just make the parts that you hash smaller,
Mm-hmm.
like
Mm-hmm.
a function
Yeah. Yeah.
or maybe even a part of a function,
Yes. AC. Why
and
not?
just throw all of this in a Git-like setting. That would be great. Also, like you could update very small parts of a software
Mm-hmm.
independent of other parts, and so things like dependency management would get so much easier
Mm-hmm.
if all imports would just reference the like commit hash of the piece of software they're importing.
Mm-hmm.
You wouldn't ever have problems like okay, this module needs to import version X and this needs to import version Y.
Yeah. Yeah.
Um, this sounds like a really good idea.
Yeah. 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 It's interesting, but I mean, it's a real good idea. I want it to happen, but I'm thinking about what kind of problems we're gonna have, and well, it looks like there must be some kind of generic editor and browser that can browse that kind of data structures, like for ipfs, for example.
Mm.
And it's not there
Yeah.
yet.
I think it's one of the biggest challenge with. Do you know of projectional editing and structure editing, stuff like that?
Well, I know that people try to like create some kind of non-text, like more rich than just text
Hmm.
editors that change structure. Yeah.
Hmm. So these are distinct fields,
Mm-hmm.
but kind of related. In projectional editing, the
Mm-hmm.
idea is that you have a model,
Mm-hmm.
a data structure actually, and you edit this data structure through different views. So a view could look just like normal program text,
Mm-hmm.
but it could also be a diagram, for example, or
Yeah. Yeah.
some other form of visualization.
Mm-hmm.
It's just separated.
Mm-hmm.
Um, think of GUI frameworks where you have a
Co-
model and a view, okay?
mm-hmm.
Um, and the model in most cases is something like an AST or
Mm-hmm.
some other data structure that really neatly maps to how the code structure actually is.
Mm-hmm.
And there's structure editors which work similar. They also have a like an AST structure, and users um, apply changes to this AST by making transformations. Um, but there are different editors, but as far as I know, none of these have really gained wide adoption.
Mm-hmm.
And I wondered what the reason for this was.
Mm-hmm.
And actually, I think a big point is that all editors that have been proposed so far
Mm-hmm.
only work for a specific language.
Yeah.
So for I don't know if I think about what I've programmed in already, I think it's like over 5 languages or so,
Mm-hmm.
um, probably even more. Um, And if I had to use a different editor for each of these languages, with a different UI and different user interactions that I would have to memorize,
Mm-hmm.
that just wouldn't work.
Yeah.
And text editing is just it just works almost the same in almost all editors. I mean, if
Mm-hmm.
you don't use Vim, for example, but I mean, 90% is just you can easily use it.
Yeah.
So probably for things like projectional editors, to succeed, you would need to create a solution that can easily be adopted to different programming languages. Like an editor that is not specifically built for a single language,
Mm-hmm.
but that can be used to program in all different kinds of languages.
But you see, as far as I understand, uh, it means that every language gonna have their own views, like their own way to interpret data structure, right?
Mm-hmm.
Because it's gonna be always different, right? Some languages are declarative, some imperative, like totally different. So basically, what we're talking about is not just editor, but some kind of platform where you can develop views that operate
Mm-hmm.
data structure. It looks like browser or even more complicated.
Yeah, it might be really complicated, but if you just make a very small foundation
Mm-hmm.
on which to build, like there's just you can define like a node,
Mm-hmm.
and define how the node is going to be displayed, and it can have an arbitrary number of links to other nodes.
Mm-hmm.
For this is a very simple idea, but you could use that to represent, for example, the AST of a Python program
Yeah.
or of another program. And if you find a user interaction that you can use to create these nodes and connect them to each other,
Mm-hmm.
probably with a very text-like experience so that it's efficient.
Mm-hmm.
Um, you I think you could build a system that's that you can use to develop any language you want, as long as people build like a definition of it into the tool. So that the idea is that you don't have to learn a totally separate tool every time you switch to a new language.
Yeah, but okay, I sort of understand, but what I'm saying is that there are always going to be differences, right, between languages,
Yes, of course,
specific,
and there should be.
yeah, and like not just differences in structure, but actual differences in interface. Because that's why we created, right? So we could use special features, extract more data from like structure and use it. For example, some kind of functions could be displayed as like graph or something. You can manipulate it. So you need special kind of view that presents code as graphics that you can manipulate. But it may work for one language. In our language, it will be slightly different rules, slightly different data types. It's like there might be a generic solution for structure editing, but for every language, there's going to be some kind of specific plugins, something like additional, and it starts to look like just like with web programming, you have some kind of similar tags, but really different JavaScript on every site, and it's always different. It's like a platform, right? With similar, with same data structure.
Yeah, probably having something like the web is the only option, because you need to have a lot of, you need to support a lot of different use cases,
Yeah.
and a lot of different languages. But you still want to have them all
in one.
in a package that's as consistent as possible.
Yeah,
And
yeah.
I think the web does a good job. I mean, you use the same technology to do very small hobbyist blog post sites
Mm-hmm.
and big enterprise sites. I mean, they're not that similar actually, but it's still the same technology
Mm-hmm.
under the hood. So maybe this would be an idea,
Yeah, yeah. Well,
but
the
also a very complex project.
yeah, but maybe there's a way to start it small, like, and make it
Mm,
useful as early as possible. Because I think the main reason that people the main reason that very interesting projects don't get adoption is that it doesn't really solve any problem that people have right now, like pain,
mm,
everyday pain that they would love to get rid of. So yeah, so maybe if there is a way to start small to solve little problem people really have, it may really work out.
mm.
Yeah.
Do you have some examples of problems you think about when you think about improving programming?
Yeah.
Some very specific things.
Yeah. Wait. So you're thinking about um,
So
mhm,
when I think about how I would make programming better,
mhm,
I always imagine have some kind of use cases that I have experienced or I have had others experience,
mhm,
and they just things that I think could be so much easier.
mhm, mhm,
For example, I worked on some interactive how's it called? Oh yeah, an explorative explanation.
mhm, mhm,
Um, so basically, it was a math thing,
mhm,
and you could drag sliders around, and things moved, and it looked really fancy.
mhm.
And I thought, okay, this is basically a very simple thing. There's just this formula, and it draws lines,
Yeah.
and you should be able to do this in like half an hour.
Yeah.
I spent like 2 or 3 days building it with some prior programming knowledge,
Mhm.
and other some of my friends wouldn't have been able to do it at all.
Mhm.
So I thought, okay, if programming was perfect, this would be way easier. And there are a couple of other things that I regularly think about, which should be much easier, but
Mhm.
aren't. And I was just curious if you have also some like use cases you always think about. Okay, this should be easier.
Yeah. Yeah. What I think about, and I like wrote down some ideas.
Mm,
Is what I would like to have in programming is time trial debugging. Time trial debugging. You
hmm
know, it's like you have code, it runs, something goes wrong. Maybe it breaks, maybe it doesn't break, but you see it's wrong. You
hmm
stop it, you go back in time, and like revert the
Until you
execution
find, yeah, until
until
you
you
find the
find,
spot where it went wrong.
yeah, you fix it,
Uh-huh.
and then you run it again, and it should run in some kind of alternative time frame, like alternative time branch. It works, or maybe it breaks again. And you're like, okay, it's not there yet. You go back again, fix it, and you reiterate this run, go back in time, fix,
Mm-hmm.
run, going back until you satisfied it with it, and then you let it go. Like
hmm
restart the part of the system, or just if it's possible to just run to the like to the current time.
hmm
And there are some projects trying to do that. I
hmm
saw some kind of JavaScript library that really like fostered that kind of style of debugging, but they really limit it. And the main problem is I/O. It's because you cannot unsend what you already sent to the socket, right?
hmm
It's not possible. So there must be some kind of abstractions, some kind of way to organize programs that would like put away this IO, let's say, isolate this IO to the point that you can you would have a lot of space where you can time travel easily without breaking things, debug it, and only when you satisfy it you can enable this IO again, and it's gonna work properly. Yeah.
This sounds a bit like you would use, for example, mocking in dynamic languages. So that instead of having the real database or the real socket, you create a very simple implementation with a similar interface.
Yeah.
So you could try it out easily.
Yeah.
And if you're sure that it runs, then you would change that for the real database or the real I/O device. But yeah, time travel debugging, I think, especially for people who are new to a project or new to programming in general, is just makes it so much more observable, so that people really can see, okay, the program I typed does these steps, and the next step goes down here, and I tried to teach programming to a friend of mine a year ago, and to me it was totally clear how things like for loop work. So there's the condition, and then the body gets executed line by line, then it jumps back and it increments the counter, and then it checks the condition again. But that was just because I was used to it. And it was really interesting to see someone who's new to programming struggle with this. Because they didn't have a mental model, and the code was just there. There was nothing moving, changing. They could just say run, and the program would produce an error. And they were stuck. They were like, okay, I won't be able to learn programming. And I think if they had a tool that would really show them what's going on, and that's exactly what time travel debugging is. Really, it's just a way to put the program into its parts and see how things work together. I think it would be really, really helpful. The problem is, I think most existing languages aren't designed to support this. For example, in Python, it's a very dynamic language, and writing a program that supports going backwards in time is pretty hard, because you would have to remember a lot of state, or just rerun the same program until the previous step, which would be bad performance. And also, like you said, a program isn't isolated enough usually to be so that you could reliably do this. If it's just a file and for some reason you delete the file, then your program stops working and so on. But still, the things like time travel debugging would be a great thing, especially for new users, I think.
Actually I don't have any when I think about such things, I don't even hope to use it in existing language. At least it's for me, it's like, at first I think about any language that could exist, that I could maybe create, and only then maybe it's gonna fit into existing languages. And I thought about this time travel thing, and I found this interesting way. It's like, do you know what like actor programming? Probably heard of.
I heard of it, but I haven't really looked into it. So I don't. It's a concurrency model, right?
Yes.
But I don't know really, much more than that.
Okay. So basically, actor is like independent process. Like you have like many actors. They communicate with each other, send messages, and that's how the whole program runs. And I thought, okay, what if actors are composed of pure functions?
Mm-hmm.
And that means that their state and their output is only depends on the previous executions, previous messages they received.
Yeah.
If so, then if we record only I/O,
Mm-hmm.
no. If we take this and if we create some kind of system where there are two kind of actors, like pure actors that consist of
Mm-hmm.
only pure functions that we can predict how they work, and dirty actors that send messages from socket, from file,
Mm-hmm.
for something that we have no control of. And we really need to remember only I/O from dirty actors, like what you read from socket, and in what order. You need to
Mm-hmm.
remember this. Everything else could be executed, produce it again. You don't have to store all this mess of data. And
You mean because it's deterministic?
yeah, because it's deterministic. And
Mhm.
and this way you can really repeat what happened before, do some changes, continue, and really do time traveling, like time
Mhm.
travel debugging, really conveniently.
Mm. Yeah, that's for sure an interesting thought as well. Do you so most people in the group want to make programming easier for some sort or make it more powerful. What would be your target audience? Would you like programming to be easier for people learning how to program, or for experts, or all the people? What's your kind of focus?
My focus, I don't know. I don't have a clear distinction. Like, my focus is produce something that people could use, regardless are they experts or beginners, but something that they would use and would be ready to pay for. So likely experts, but not necessary.
Okay.
Yeah, so that it could live and like develop.
I think a lot of people try to get more new people into programming because they are not as biased as experts. Because experts most likely have a very strong opinion on their tool, their favorite programming language, and so on.
Yes.
So it's really hard to convince them, hey, try this new thing. Probably new users are easier in that regard. But on the other hand, I think new users usually struggle the most learning how to program, or just they probably have the biggest they can have the biggest improvements because experts just, I mean, they know what they can do, what they can't do, and they over time get pretty good at just playing computer in their heads. But I think for new users, probably the possible gain would be even more. But still, you would need to find new users who want to try out your new programming language. And most people say, yeah, what's everybody programming? And then the answer is, yeah, do Java or C++ or Python.
Yeah.
And they say, yeah, okay, I'm going to do this.
Yeah, right. I mean, I think even if you have new users who really just came into programming and they really like your tools, your tool, in order for your project to really develop and fly, your users should find a way to earn money. It's like, or produce some software that someone buys or something. So it's going to be profitable for them, and then they continue to use it. If it's not profitable, if there's no prospects, why are they going to use that kind of platform? Even if it's convenient, right? That's why few people use really exotic languages, because it's cool to play on the weekend, but then you have to earn money, and
there's no jobs for it.
Yeah. So
that's right. How long are you planning to do this talk?
I mean, right now?
Yes.
How much time I have, you mean?
Yeah.
I don't know, maybe 30 minutes more, or maybe now. How do I feel?
Okay. I think I would have to leave in, I don't know, 10, 15 minutes, if that's
Okay,
okay with you.
yeah, fine.
Yeah. Okay. So maybe we could have one more topic.
Mm-hmm.
Do you have anything you'd like to talk about?
Let me think. Yeah, I have this one other thought that I recently wrote down in chat, but um, I just find it interesting.
Hmm.
Is that it seems like people usually think with visual abstractions or with some kind of muscular feelings, because like I heard that Einstein, like when he described how he
Oh yeah,
understood, like
you could really feel his formulas and stuff, right?
yeah, it's like some kind of muscular feeling or something,
Mm.
like some forces act on each other or something. And also Richard Feynman also told that he first imagined visually this kind of diagrams like for
Yes.
quantum physics. And also when you do calculus, you always draw graphs and trigonometry. You have to have this circle, otherwise you just don't understand. You cannot
Hmm.
really think symbolically. And I thought, okay, seems like most of the abstractions are really connected to things we experience.
Hmm.
It's like, and it seems to me that we cannot really work with abstractions that not presented in our real life. And I thought, okay, that means that we should strive to use that kind of abstractions that we can perceive in the world, but
Hmm.
in the programming languages. But right now it's not there. For example, we have programming abstractions that do not exist in the real world, but exist in programming.
Hmm.
For example, you can have a closure that
Hmm.
captured socket as a variable. So you have this
Hmm.
function that you call, and it behaves totally differently, like because it has communication with something outside.
Hmm.
It's like it never happens. Like you don't have like Apple that suddenly turns red or something. It doesn't behave. It doesn't. If you work with object, it doesn't change its behavior just because of
Hmm.
out of blue. Like it has to be in some kind of space. It should be warm or cold.
Hmm.
There must be some kind of context switch. So for us, it's hard to work with that kind of objects to perceive
Hmm.
them. Yeah, and I thought, it's really interesting to write down what kind of experience we have as humans, as monkeys in the past, like
Hmm.
what kind of experience, evolutionary experience we like um, accumulated, and then produce that kind of abstractions that really similar to the world that we have.
Hmm. Yeah, that's a good idea. Um, the first thing that came to my mind
Mm-hmm.
was the Kill Math essay of Brad Victor. I think it's there
Uh huh.
where he describes the thing you told with Einstein,
Mm-hmm.
that he could really feel what he was doing.
Mm-hmm.
Um, and I think a very big point in making programming easier could be to make it map better to what humans are good at.
Mm-hmm.
Um, for example, humans are very good at spatial things,
Yeah.
remembering how a building works, or finding a way in your city or so.
Mm-hmm.
And this is a skill that has built up evolutionary
Mm-hmm.
over thousands of years.
Yeah.
And we still have this, even though we don't need it as much anymore.
Mm-hmm.
Um, but for example, if you take programming, you don't need that skill at all.
Mm-hmm.
There's no spatial arrangement of your different functions.
Yeah. Yeah.
It's
Yeah.
just somewhere on the screen, and if you scroll, it's somewhere else.
Yeah. Yeah. Yeah.
Um, and so it's really hard to get an overview, like
Yeah.
you would get an overview if you just look at a map or so. So maybe introducing more abstractions um, that can be understood by humans, or that use skills that humans have,
Mm-hmm.
could be really interesting. Yeah.
Mm-hmm.
But I don't know, other than spatial thinking, if there's other parts that could be used. Maybe tactile stuff, but that's
I
really
think
hard technically.
also music. For example,
Music?
when I work on my computer,
Uh-huh.
when some kind of program uses 100% of CPU, you hear the fan start to running, and
Oh yeah.
and you understand. Oh, something went wrong.
Uh-huh.
I think we could develop this and produce some kind of sound that show not like the 100% CPU, but some
Mhm.
more like subtle problems. Like when your say garbage collector does something, you see some kind of click or something, and you may notice some kind of patterns that
Mhm.
can tell you that there is a problem.
Yeah. I thought about directories
Mm-hmm.
some time ago, because if you look at two folders at your PC,
Mm-hmm.
one is empty and one contains 100 gigabytes.
Yeah.
They both look exactly the same.
Yeah.
There's no, I mean, in the physical world, if you have an empty bag
Yeah.
and a bag that's absolutely full,
Mm-hmm.
you could see the difference, or
Yes.
just poke at them and see it. Okay, this one's empty and this one has something in it.
Mm-hmm.
And these physical properties are really helpful.
Mm-hmm.
But in computers, it's more like a black box. You have this icon and it looks the same whether
Yeah.
there's an operating system in the folder or whether it's just a single text file. So maybe um, making things appear more physically
Yeah.
would help in understanding them.
Yeah. I can almost imagine like some kind of file explorer where yeah, like all files and folders are have relative size, like bigger
Hmm.
bigger, smaller smaller, but also the most commonly used in the center and like rarely used in the around the circle.
Mm.
And it's really because you open, you hit the center, something that you use most of the time is somewhere in the middle, and
Mm.
rarely used thing, like regardless of how large it is, it's still on the like on the outside. Could be really convenient
Mm.
and fast, efficient for
Yeah.
humans.
Yeah, also it's taking advantage of our visual abilities.
Mm-hmm.
It's Humans are so good at analyzing large amounts of data if they're represented as a diagram, for example.
Mm-hmm.
If it's a really good one,
Mm-hmm.
it's much easier to process than, for example, just a bunch of numbers.
Yeah, absolutely.
And I think we are not taking advantage of this in programming
Yeah,
as much as we should do.
yeah, but
But also for things that need to be exact, like a program needs to be, it's way easier to design these things, because it's in most spatial or things or visual things,
mm-hmm.
um, it's the user needs to have an understanding, but if it's slightly off, that's okay.
Mm-hmm.
Um,
Yeah,
but for a program, if there's something slightly wrong, you probably don't understand what it's doing. So I think you need to be really careful with this. And the other point with the fan noise,
mm-hmm.
that's really a very good indicator.
Mm-hmm.
Most of the time when I crash my computer and run out of RAM, for
Mm-hmm.
example,
Mm-hmm.
I notice first because the music stops.
Yeah,
And
yeah.
if the music stops and I see I'm still connected to Wi-Fi, I know, okay, something terrible is going on.
Yeah, yeah.
And that's that's a very that's like a side channel,
Mm-hmm.
giving you more insight,
Yeah,
but it's a powerful one. And you're right, probably focusing on these kinds of things would be of great help.
yeah. So cool.
Okay, cool. I think I would end the corner. Is there something more you want to say?
Um, no, I think I almost, I think I told almost all ideas that I had recently. Like some of them
Okay.
are still there
Uh-huh.
in the pile of paper, but yeah, I think I pretty much described almost everything I thought about like recent months.
Mhm. Yeah, that's really cool. I really enjoyed talking to you.
Okay.
It was great. And probably we can do this again sometime.
Mm-hmm.
Okay, so have a nice evening.
Mm-hmm.
Um, and hope you enjoyed it as well.
Yeah, yeah, it was interesting.
All right.
Okay.
So goodbye.
Mm-hmm. Bye.